Hello, this is Mr. Stansbury. I'm going to take you through the notes on solving a system of equations. At the end of this, you should be able to say I can use substitution to solve a system consisting of a linear and nonlinear equation, and I can determine when there are no solutions. So first thing we want to do is look at our three possible solutions of a quadratic. That's the parabola, and a linear, the straight line. Okay, we could have where they intersect at two spots here. So our solutions here would be at -1, and 2, 2. Or it could intersect just at one spot here, which in this case is at 1 and -1. Or they could not intersect at all. So there'd be no solutions here. Okay, so that's the graphing part. You could graph them and find where they intersect, but really the fast and more accurate and just the better way to do this is with algebra. So what we're going to do is we're going to find the real solution or solutions of each system algebraically. Okay, so we have two equations. Here's our linear and here's our quadratic. Okay, so since both of these things equal y, we're simply just going to substitute one into the other. So wherever I see y, I know I can plug in -3x minus 8. So I'm just going to plug that in for this y right here. So we're going to end up with -3x minus 8 equals x squared plus 4x plus 2. Okay, we're going to want to make one side equal to 0 like we've been doing all along here. So it means we're going to want to move this 3x and this 8. Get rid of those. So I'm going to add the 3x to the 4x and add the 8 to the 2 here. And we will see what we get. We end up getting 0 on one side, which is good. Then we got x squared. 4x and 3x is 7x. And then 2 plus 8 is 10. Now, hopefully this thing will factor out nicely. If it does, then we'll just factor it and away we go. Or if it doesn't, we can plug it into the quadratic. Or if you just really don't like factoring and you want to just plug it into the quadratic formula and go from there, you are more than welcome to do that. So I'm going to look at this here, and that's a 1. So 1 times 10 are factors of 10. 1 times 10 and 2 times 5. It's going to be these factors of 10 that add up to 7. We actually have some. So this will factor. For me, I think it's a lot faster to factor it when we can. Again, if you're just not comfortable with factoring or you just don't like factoring, you can plug it into the quadratic. It's a little bit more work, takes a little bit more time, but it will always work. Okay? So anyway, this one's going to factor, so I'm just going to factor this one out. Okay, so let's see. We know that we've got x times x to get the x squared. 10, we figured out, is going to be 2 and 5. And these have to add up to a positive 7, so that means it's going to have to be positive 2, positive 5. 2 times 5 is positive 10. 2 plus 5 is positive 7. So we know we've got the right factors there. And then we want to go through, and we know that if we have two numbers multiplied together to get 0, either this has to equal 0 or this has to equal 0. So we're going to do x plus 2 equals 0, and we're going to do x plus 5 equals 0. Subtract 2 from both sides. X has to equal -2. Subtract 5 from both sides. And x has to equal -5. Okay? So these are our two x values. We actually got to find in this case, the solution is going to be the ordered pair, the x and the y. So right now we've got two x's, so we're going to have to plug both those in to come up with our two y's. So this is going to end up giving us two solutions, or actually better be both of those. So we've got -2 we know is one of the x's, and -5 we know is the other x. So now we got to plug those in to either one of these equations to figure out what the y is. I'm going to choose this first one because that looks a little bit nicer. So I'm going to do this. Y equals -3 times, I'll draw a little arrow down here so you know where that came from. -3 times our x in this case is going to be -2 minus 8. And then we're also going to do the other one. Y equals -3 times -5 minus 8, right? -3 times -2 is 6 minus 8. So y is -2. So we're at -2. -2 is one solution. And then -3 times -5 is 15 minus 8 gives us 7. So negative 5 and 7. So these are our two solutions. Okay, not that they're asking you to graph it, because they're not, but if we were to graph this, just so you can kind of get an idea, if we were to graph this, it's going to look something like this, and these are going to end up being our two solution points. Okay, just so you kind of get an idea. All right, let's take a look at B, but maybe before we do that, let's take a quick little comedy break.
There's two reasons I don't like body wash. One, when I get out the shower, it feel like it's still on me. Two, it uses words that I can't readily identify with, such as exfoliation. That don't even sound positive. Why are we doing that to ourselves? Sounds like something you lose friends over to me. I can hear the conversation now. You know, me and Mike was cool. We grew up together. We was like this, but ever since the exfoliation. He not the same dude no more. It's because I'm moist, that's why I'm against my will.
All right, let's take a look at B here. So same idea. I'm going to take the smaller one, the linear one, and plug it in for that y right there. So we get 72 minus 12x equals negative 2x squared plus 16x minus 26. So let's get rid of that 72. And then let's get rid of that 12x. And so over here we end up with 0, negative 2x squared. 16 and 12 gives us what? 28 plus 28x. And that is going to be 98. Ooh, okay. So that's a bit of a doozy there. That's all right. But if you look here, look. Negative 2, positive 28, 98. Those are all even numbers. So let's divide everything. And to get rid of that negative, let's divide everything by negative 2. So we're going to factor a negative 2 out of all of these. And we're going to get 0 equals x squared minus 14x plus 49. Okay? So again, we could plug it into the quadratic, or we can see if it factors. There's a 1 out here, 49. Factors of 49 are 1 times 49 and 7 times 7. Do either of these add up to 14? Yep. So those would add up to make things nice. Now, let's do this. Let's just pretend we didn't realize that worked. And let's pretend that we forgot to factor a negative 2 out of that. So we're going to go back, get rid of all that. We're back to here. Let's just plug this into the quadratic just so you can at least see two different ways, right? So our quadratic formula, negative b plus or minus square root b squared minus 4ac all over 2a, right? So in this case here, we get x equals negative 28 plus or minus square root of 28 squared, yeeps, minus 4 times a, which is negative 2, times c, which is negative 98. This is going to be a big one. All over 2 times a, which is negative 2. So you can see why it would be beneficial to maybe go through and factor some of these, but it's okay. We can do it this way too. So let's bust out our calculator to see what these things are going to be. Okay, here's the part that's just under the radical. So here's just our stuff under the radical. 28 squared minus 4 times. Now, when you're multiplying by a negative number, make sure you push this negative button instead of the subtract button. It makes a big difference. Okay, so we push all that. And ooh, look at that. We happen to get 0 for this. So we end up, this simplifies to negative 28 plus or minus the square root of 0 over negative 4. Now, really, the square root of 0 is just 0. So really this is just going to equal negative 28 over negative 4, right? Because you're adding 0 and subtracting 0 is not going to do any difference. So we get x equals negative over negative is positive 28 divided by 4. It's going to give us 7, isn't it? Okay, so we now know that our one solution is just going to be 7 for the x, and now we got to figure out what the y is. So we're going to plug 7 into either one of these equations. I'm still going to pick this linear one here, and we get y equals 72 minus 12 times 7. Let's see, 12 times 7 is going to be what? Minus 84. So we get y equals negative 12. So our one solution here is going to be 7 and negative 12. And again, they're not asking you to graph it, but just so we kind of get an idea, this is a negative 2x squared, so it looks something like that. And then we got this negative 12x. So it's going to look something like this, where you just get one intersection point, and that's going to be at 7, negative 12. Okay? All right, that's all we have for solving a system of equations. If you have any further questions, please feel free to ask. Thanks.